So when we look at this next page that we've got here, we're just going to recap with some of the ideas from year 12. And the idea of me recapping some of these year 12 ideas is because we all need to make sure that we're fully on board with these ideas before we make it get harder and more complicated. So, you know, forgive me if this is something you know, and forgive me if you do physics and you're like, yep, I understand this. Just have a relax while I talk through this. So it says Newton's second law, and I've written this out in a long way, but it says an object will accelerate if there is an overall resultant force on the object. The acceleration is proportional to this force and inversely proportional to its mass. Basically, F equals ma. Okay, don't worry about all of the wording of that. You just need to know your formula F equals ma. F, though, is not the force, it is the resultant force, which we're going to explain in a second what that means. M is mass and A is acceleration. Because it's acceleration here, acceleration is probably going to be a vector quantity. And when I say vector, it's either going to be positive or it's going to be negative, referring to the direction that it's going in. The resultant force, here we are breaking this down a bit more. The resultant force is found by finding the difference between the forces in one direction and the forces in the opposing direction. This tells you the overall force in one direction. The way I would have explained this if this is year 12, I would say it's almost like the forces are like doing tug of war. Remember, like at sports day? And like overall, if we look at this diagram we've got here, we've got 45 pulling it to the right, and we've got a 10 and a 5 going to the left. So overall, the overall result will be that it's a 30 to the right, because 15 of this 45 are counteracting these resistance forces that we've got here. So just applying this into a very simple example we've got here, I've said it's clearly going to accelerate to the right as there is an imbalance of forces. However, the up and down forces will be balanced because it's not accelerating up and down, it's just accelerating to the right. And to work out the acceleration of this, we use F equals ma. This is something that I feel not everybody will do consistently, so I want you to listen, you know, no matter what your background is here. You should, for F equals ma, you should put all of your values directly into the formula. You shouldn't work out what the resultant force is and work out what the mass times acceleration is and then make them equal. You should put everything directly into the formula for F equals ma to begin with. So you get your resultant force is the forces to the right minus the forces to the left. So you have 45 minus 10 minus 5 equals the mass times acceleration, which is 2a. Solving that, you get a is equal to 15. So the particle will accelerate at 15 meters per second to the right. We're just going to do that with two really simple examples here, and this is now coming under our topic of dynamics, okay? Dynamics is just referring to things that are moving, right? The previous thing, what was the previous topic called with forces? Statics, good. Statics not moving, dynamics means that it's moving. It says in each situation, the forces acting on the body cause it to accelerate as shown in the diagram. Find the value of A. So this one I've got here, it's accelerating downwards. So Sarah, which is going to be bigger, 2g or 8? 2g has got to be bigger because we've been told it's accelerating downwards. Also, we can work out 2 times g is going to be 19.6. So using, and this is how I'd like you to write this out, we're going to use F equals ma, and we're going to take downwards as our positive direction. We're going to be saying that downwards is positive. So we're going to have 2g minus 8. We're saying 2g minus 8 is going to be our resultant force. The mass is 2, and the acceleration is the thing that we're looking for. So we can work out 2g minus 8, that's 2 times 9.8 minus 8, that is 11.6, I think. 19.6 minus 8, yeah, is equal to 2a. So the acceleration is 5.8 meters per second squared, okay? Pretty straightforward, just going straight into F equals ma. Notice how I do it all at once. I don't do it as two separate things. Habib, what's going to be my F equals ma for this one?
100 minus 8g equals 8a.
Good. So my resultant force now, I took the upwards direction because this one is bigger than this one, so it's going to be moving upwards. 100 minus 8g equals 8a. So we'll do that and then divide it by 8. Anyone got that calculator ready to go to save me finding mine? 2.7. Okay, I'll believe you if it's wrong. That's Habib's fault, not mine. I've just put a few things down here. Resultant force is just a key word we might use if I'm going to be describing this. Resolve, when I say the word resolve, do you know which bit I'm referring to when I say resolve? Yeah, when I'm talking about looking at the up and the down part. So I'm going to resolve the forces in this direction. It's saying like what's the overall force going in that direction. When I use the word resolve, we're like considering forces in that particular direction. Okay, so we are going to just bring together some of the ideas that we have done previously. You're going to do these few questions that we've got here. I might do this one very, very quickly at the top as a bit of a recap. One thing that I want you to do before you start doing these diagrams is it printed funny. This is not supposed to say 60. This is supposed to say 6, so it's as it should be here. So if you can change that to 6 on the diagram. And I think that was the only thing I needed to point out about that. It shouldn't say 60, it should say 6, and it should have an arrow at the top, okay? If I do this one at the top here, now we know that angled forces can be split up. I'm going to resolve this, and Sarah, you know I'm going to pick you for this. So I've got these two sides of the triangle here. What are they going to be? And is it going up or is it going down? How do you know? Good, because it's going across and it's going up. And so the one running along the bottom is 10 cos 30. Now I want you to do a new diagram. I don't care if you are experts on F equals ma. I want you to do the new diagram because I know where this topic goes and I know it becomes more complicated than things you may already have done. So I'd like you to do the second diagram, please. Your second diagram, Amara, what forces have I got going to the right?
10 cos 30.
Good. What forces do I have going up? R and 10 sine 30. Any other forces that I need to add?
2g.
And then 2g. Okay, so when I do the value of r, this is what I want you to do in the third box. To find the value of r is not going to just be 2g. Someone in the other class said to me, and they were actually someone who did physics, I couldn't believe it. They said, oh yeah, well the value of r is just the weight. The value of r is always the weight, which is completely not true. The value of r is the weight if it's just sat down and nothing is happening to it at all. But in this case, we've got a box and someone's kind of like pulling it upwards and along. By pulling it upwards a bit, what will that do to the normal reaction force? It will decrease it because it's making less contact with the surface. So the pushing up from the surface is going to be less. And you can see that because r plus 10 sine 30 is equal to 2g. So finishing that bit off, you get r equals 2g minus 10 sine 30, which works out as 14.6 newtons. And that was because we resolved in the up and down direction. We're then going to do F equals ma, going along. There's no resistant force, so it's just 10 cos 30. That's your F equals the mass times the acceleration. So whatever that is when you divide it by 2, and I want them as decimals, okay? So you need to find new diagram, value of r, value of a. After you've done those 3, you've got 3 more that you can try on this page as well, okay? Off you go.